Welcome to my video. Hi everyone, my name is Fatma Sıla Yazar. I am a student in Bilkent University. My major department is Industrial Engineering and I am going to present my Physics 101 project. I learned from physics class that objects thrown at the same speed but at different angles will follow different vertical and horizontal paths according to projectile motion equations. My aim in this experiment was to observe whether objects with the same initial speed will follow the same path horizontally when thrown at angles complementary to each other up to 90. The launcher was used to change the angle between the item and the horizontal axis. It was the main object in this experiment. I used the ball to leave a mark on the carbon paper. I also needed a compression bar to compress the ball into the launcher. Carbon paper was particularly important in observing appropriately my aim because of its marking feature. The measuring type was used to measure the distance traveled. Lastly, a timer was also required to measure the total flight time. Let's look at my experiment records. My theory was that objects thrown at the same speed with complementary angles would take the same path horizontally. This theory was based on trigonometric ratios in projectile motion formulas. I repeated the experiments several times for the angles I determined and recorded the results. Although I couldn't fully prove my theory, I found a result that supported it. Since friction and external forces were considered ineffective in these formulas, it was of course expected that they wouldn't not match real-life experiments exactly. I calculated the margins of error according to how far behind they were in terms of complementary angles, because my expectation was to obtain very close values. I can say that the biggest reason for this error was the recoil force on the launcher device. In order to reduce these errors, we needed an ideal environment to minimize friction on a gun fixed to the table. In conclusion, I proved my theory partly. Thank you for watching.